Hello everyone. So with this additional video, as promised, I'm gonna give you links and directions on how to reach the details and extra videos on top of the one from number one about the testing methods, something about the Canadian Museum of Nature, all that extra stuff that I did not cover but alluded to in video one. So without further ado, let's get started. Great. Thank you so much. I want to thank you for being here. You could have been anywhere else doing something else, and you chose to spend some time with this video. I promise it's a lot shorter because it's simply a springboard to get you to other videos that I've linked for you for your interest. Just a reminder what this topic is about. This is part 2 or video 2 about the soils videos, right? We spent some time looking at figuring out why we don't want soils under buildings behaving like quicksand, as in this video is kind of showing. Okay, so let's start out with the Canadian Museum of Nature. I promised you that I would show you a little video or link for you a little video at the bottom that shows a description of the structure for the Canadian Museum of Nature. What I'm going to do is I'm going to link that video. It's a couple of minutes long, as well as the full documentary about the Canadian Museum of Nature. They're both YouTube videos, and I think they're excellent. The next ones are going to be links to videos done by one of our professors here at Algonquin College about these tests that are done in the lab. The first one, which we covered, I guess, in part 1 of this video on soils, was the sieve analysis test, or the particle distribution test. That's where you have a whole bunch of sieves stacked on top of the other. Each of these sieves have meshes in them, and the widely spaced apart meshes at the top capture the big pieces, and the very thinly spaced apart meshes at the bottom capture the very small pieces. And these are good only for non-cohesive soils. That is, soil particles that are more than 0.075 millimeters in size. Okay, so non-cohesive soils. And if you're not sure what I mean by non-cohesive soils, go back to part 1 of the video because it will chat about non-cohesive soils, cohesive soils, and why they're important, say, for the slope of excavations. Okay, so that will be linked for you. The sieve analysis or particle distribution test will be linked for you in the description at the bottom. I'd like to follow that up with the 2 tests that are done to determine the plasticity index of cohesive soils, right? These are fine-grained soils. The first one that's shown on the left-hand side is done for the plastic limit test, for the plastic limit determination, and the one on the right-hand side is for the liquid limit determination of the same sample, okay? So I'm going to link both of those for you in the description at the bottom. These are the 2 tests, the Atterberg tests, that are done to figure out the plasticity index of fine-grained soils. And if you don't remember why this is important, go back to part 1 of the video, which chats about plasticity index, why it's important, and what happens when we know the values of liquid limits, plastic limits, plasticity index, and comparing, say, 2 different samples of soils. Then, we're almost there. I'm also going to link for you some additional YouTube videos, 3 that you see here, that show examples in the field that I found on YouTube, the World Wide Web, of liquefaction. That's the top left video right now. Also of shrinkage in soil and how it affects buildings in the top right corner right now, as well as a real-life case scenario of the Risa landslide in Norway. This is studied and well known in the circles of geotechnical engineering because it's a massive example of liquefaction, and it's a well-done documentary. I'm also going to link for you examples of how some students here at Algonquin College built an apparatus to mimic liquefaction in soils. Now, they didn't use liquid, they used a fluid, they used air. But I'm going to link 2 videos from Algonquin College by third-year students whom, as part of their project, did this. As a bonus, I'm also going to link for you a video to a tower in San Francisco. There's a couple of videos about that, how this huge, multi-hundreds of millions of dollars tower in San Francisco, meant to be a jewel and very expensive, and it's sinking, and what they're doing about it. Okay? So those will all be linked for you in the description at the bottom, which brings us to the end of part 2. That's it, right? You can go and explore some of these extra videos. I won't test you on your knowledge of the tests, just that you're aware of them and kind of what's involved with them, but not the details because you can't be asked to reproduce them. Thank you so much for your time and have a lovely day.